generated 1 million random numbers based on a very complex quantum distribution. Because the nature of quantum mechanics is very complicated, it is very difficult for a classical computer to simulate random numbers from a similar distribution. If you believe IBM, it would take a supercomputer 2.5 days. If you believe Google, it would take 10,000 years. But it would not be accurate to say that the quantum computer is more powerful than the classical computer. They are doing different things. All the quantum computer is doing is observing its own qubits, while the classical computer has to simulate what the qubits would do. So it's really not comparable. You might ask, what is the practical use case of sampling qubits 1 million times? The answer is absolutely nothing. The Google quantum computer cannot do anything useful. The quantum supremacy was purely a demonstration to show that they can indeed manipulate the qubits and observe them. The inherent fragility of qubits makes scaling up quantum computers very difficult. But even if you can create a quantum computer with tens or even hundreds of thousands of qubits, it's not immediately clear what you would use it for. There's a lot you can do with a regular computer today. You can write Word documents and browse the web. More powerful computers can render complex graphics for video editing or video games. The billions of transistors on the CPU can perform massive quantities of calculations at extremely fast speeds. Everything is expressed in zeros and ones, and there is no uncertainty. So when you're clicking around on your computer, it will never make mistakes. Assuming no software issues, the computer always does exactly what you tell it to do 100% of the time. Due to the inherent uncertainty of quantum mechanics, a quantum computer will never be able to operate, say, a web browser or a video game. The day-to-day things you do on your laptop will never be done on a quantum computer. The main theoretical use cases of quantum computers are generating random numbers and simulating quantum phenomena. So what can a quantum computer actually achieve in the real world? One of the most talked about use cases of quantum computing is breaking internet encryption. Today, almost all encrypted messages sent over the internet are encrypted using a method called